Hello guys, hello everyone, welcome back to this session of AIML. It's gonna be a year-long session where you're gonna learn everything that you need to become a successful data scientist. So hope you guys are enjoying this session. Today we're gonna learn. It is a continuation of previous session for supervised learning. So please guys, please make sure that you guys are looking into all the previous videos so you can have a better understanding of what we are just saying. So today the session is a continuation of previous session of supervised learning regression. So today we're going to say evaluation metrics for regression model. Guys, let us see why we need evaluation. Okay, whenever you are having a model, you can identify the performance of a model only by using regression trace. So like for regression, I'm just saying, like, if it is a regression model, if you want to find how the regression model is working, okay, then we need a evaluation metrics. So we are having different evaluation metrics to calculate the performance of the regression model. First is mean squared error. It measures the average square difference between the predicted and actual value. That's it. Okay. What is the predicted value? And what is an actual value? That is, what is the actual value present in the data, and what is the model predicted value? And we are getting the average value. Then root mean square value is the root square. That is square root of MSE. Provides an error in the same unit as the dependent variable. Okay. First it mean square error. Next just root of it. That is root mean square error. Squared error. That is R squared. Explain the proportion of variance in the dependent variable explained by the model. That is like a accuracy score for the regression model. Adjusted R square. So it accounts for the number of independent variables in the model penalized for overfitting. Okay, due to overfitting, what happens for that is one of the feature or metrics that can give by using the adjusted R square. So these are the ways that we can evaluate our model, because like we don't know whether our model is working properly or good or not. So for that we are having different metrics. Using these metrics we can say, okay, my model is working good, or no, my model is not working good. So like that we can able to control. So yeah, this is all about the evaluation metrics for regression model. Yes sir, over to you.
Yes. So, evaluation metrics for regression models. So, what are the evaluation metrics? So, we are going to discuss that, okay, for regression models. So, first is mean square error, MSE. You need to remember this with short form, MSE. Measures the average square difference between predicted and actual value. So whatever was predicted and whatever is actual, so we compare that. Okay, so with mean square error. So then we have second root mean square error, which is RMSE, short form of it. So square root of MSE, it is the square root of MSE, mean square error. So RMSE is it is square root of MSE, okay, and then provides an error in the same units as dependent variable. So this is how we can predict the errors or on the dependent variable or whatever uh, as per the data. So R squared is explains the portion of variance in dependent variable explained by the model. Some portion R squared. So you are not going to do it on the entire data, but some portion of variance in the dependent variable. You will not entire, okay? So you can use R squared, and then adjusted R squared is where accounts for the number of independent variable in the model penalizing the overfitting. So this helps us to penalize the overfitting, adjusted R square. So these are different evaluation metrics for regression models to evaluate, okay, to evaluate the regression model. So we use these four models and metrics to evaluate the regression model. Let's move to the other slide. Thanks.
Yeah guys, so next we are having some assumption for this regression model. Regression model rely on a certain assumptions, okay, about the data to ensure accurate and reliable result. First is linearity. A linear relationship exists between the dependent and independent variables. So where you can apply this regression model. So you should be an assumption, or the data set should be linearly distributed, then only you can apply this model. Then independence, error terms are independent of each other, that's a major thing. Okay, so if you are having error in different terms, then it is acceptable. Okay, it should not be in same. Okay, then normality, error terms are normally distributed. And one more thing is, we are having normal distribution, it's like a bell shaped curve, we should have like that. Then we are having homogeneity, the variance of the error terms is constant across all levels of the independent variables, and it should be same for all the independent variables. Okay, so these are the assumption that we need to have. Okay, only when the data set process this assumption, we can apply the linear regression model or regression model. We otherwise we cannot able to do that. Okay, so yeah, that's the thing, because like these are the major thing that we need to have in order to apply the regression analysis onto it. Yes sir, over to you.
Yes. So assumptions, there are some assumptions. We have four assumptions for regression models. So uh, the criteria, there are regression models rely on certain assumptions about the data to ensure accurate and reliable results. So accuracy and reliability are two factors. Huh? Uh, Okay, so one is linearity. We have linear relationship. Linearity means linear relationship exists between dependent and independent variables. So then we have independence. So error term are independent of each other. So the uh, the errors are independent. By nature, you can see the word independent means they are independent. They are not dependent. Independent errors. Terms are independent each other. They are not. They don't have any relationship. So then we have normality. Error term are normally distributed. So normality is no, like they are normally distributed. There is no problem. So that shows the normality. Okay. Then we have homodensity. So so a variance of error term is constant across all levels of independent variable. So here we need to understand the variance of error term is constant. The variance of error term is constant. It is not, you can say, it is not continuous. It is constant. It is constant. There is no variability in it. Okay, across the levels of independent variable. So that is why it is, if you see homo density, homo means it is same, it is not different, it is constant. So when it is constant across all levels of independent variable, so that this is called, this is the assumption of regression models. We have these four models. So this is how we use these: linearity, where the relationship exists between the independent and dependent variables; independence, where the error term are independent of each other; normality, where there is a normal error terms are like normally distributed; and homodensity is the variance of error terms is constant across all levels of independent variables. So these are four. So conceptually deeply understand these terminologies, guys, because when we go for application, so you have to apply them. If you don't know the definition, if you don't know conceptually, you have not absorbed or digested properly this terminology and concepts, so then you won't be able to use them properly. So you need to have concept clarity very, very clear, so that you can use them properly in your models and get success. Thank you.
Yeah, so moving on, we are having interpreting regression coefficients. Okay, so guys, this is very important. So because like everything gonna be a package, we are just installing and then we are using, importing and using, installing, importing and using. Okay, but we need to know how to interpret it. So regression coefficient represent the change in dependent variable for one unit change in the corresponding independent variable. So whenever the value of the independent variable changes, consider we're going to predict the price of the house. Okay, so house price is the dependent variable, independent variable is the size of the house. Okay, whenever the size increases, the price of the house increases, right? So uh, the where size is a dependent variable, like independent variable, and the price is independent dependent variable. Okay, price is dependent variable, and which is depend on the area of the house, which is independent variable. So how it is changing, that is what major thing. First is positive coefficient. The positive coefficient indicates a positive relationship between the independent variable and the dependent variable. That is, if the house size increases, the price of the house increases. Negative coefficient, a negative coefficient indicates the negative relationship between the independent variable and the dependent variable. Consider if we are having heart disease. Okay, so whenever the cholesterol level increases, heart disease also increases. But consider in some scenario, consider there is some x value, okay, which increases but heart disease decreases, mean that is called as a negative coefficient. Zero coefficient, a zero coefficient indicates no relationship between the independent and dependent variable. Consider, okay, we are having something called as okay, let us put the example in this way. Okay, um okay, house, okay, house size and the student passed or failed, is there any relation? No. Okay, that is what zero coefficient. So this is how you need to get the interpretation about the regression, guys. So it will be a positive coefficient where both of them increases, negative coefficient one increases and one decreases, zero coefficient there is not at all any relationship between them. So that is what how to interpret this regression coefficient. Yes sir, over to you.
Yeah. So interpreting regression coefficient, we need to understand the regression. In regression, coefficient represents the change in the dependent variable for one unit change in the corresponding independent variable. So, like if the price of coffee increases, okay, so then people will start drinking tea, I'll say, because if something increases and the price of tea remains same, like if it is less, so then people will start drinking that. If um, and this is a economics concept, and again it comes from stat only. Economics is all about statics. So here we are using the same interpretation regression, they use it. So if something goes negative, something else will go positive. This is they are dependent. If they are dependent variables, so what will happen is it will change. If it is independent, then they will not change. That is the difference. Like if there is a dependency of positive and negative coefficients, then there would be a change. If there is no dependency, they are not they are independent, then there won't be a change. There won't be a variation because they are not dependent on each other, right? So if they are dependent, then there would be a change. So positive coefficient means positive correlation indicates positive relationship between the independent and dependent variable. So there would be a positive a correlation. Like uh, there would be a positive coefficient indicate positive relationship would be there. So so if something goes up, it will the something else will also go up. So this is how the positive relation. And negative coefficient indicates the negative relation between independent and dependent variable. So if something goes down, something else will go down. So because there is a relationship of negativity, like okay, if suppose if BJP loses the election, the stock markets will go down. So like negative correlation, there is a negative coefficient. If some other if suppose if Donald Trump wins the US presidential elections, and markets will go up. So this is what positive and negative coefficient matter. So it the dependents will behave like that, independents might not behave that way. Okay, so zero coefficient is uh, where which indicates the no relation between independent and dependent, where there is no relationship. Okay, so in positive there would be, if something goes up something else will go up. If something goes down, that would be negative coefficient, something else will go down. So you're dependent and independent variable, right? And in zero, if something, so there won't be any change in dependent and independent variable, dependent and independent variable. So this is how it will behave. Yeah, let's go to the other session.
Yeah. So the next slide, guys, like regularization techniques in regression. Okay, so regularization techniques are used to prevent overfitting in regression models, improving their generalization performance. So, guys, now we will tell what is meant by overfitting and underfitting. Okay, I think it's a right scenario to explain what is overfitting and underfitting. Whenever you train your model, there occurs two things. One is overfitting and underfitting, and we need to pass in between that so that we can get the generalized model. What is meant by overfitting? So let us consider the model as it is trained all the data perfectly, and it can able to give all the 100% of accuracy for the training data, and it not at all useful for the testing data, then it is called as overfitting. Whereas underfitting is something like you train your model but model doesn't train for the training data itself, then it is called as underfitting. Okay, so underfitting means the model doesn't work for the training data itself. Overfitting means the model works 100% for the training data and not for the, not even a single percent for the test data. That's it. That is what overfitting, underfitting. So this regularization is used to avoid the overfitting. That is, it will make the model generalized rather than memorizing everything. Okay. First is lasso regression. So lasso means it will shrinks the coefficient of less important features towards zero, potentially eliminates them entirely. Okay. The thing is, it is able to avoid this overfitting by eliminating or removing it to the zero value. Whereas a ridge regression is like shrinks the coefficient of all the features towards the zero but does not eliminate them completely. In the lasso, the thing is completely eliminated. Okay, it will try to eliminate the uh, term which is, or a feature which is creating overfitting, but in rigid it was not able, it will not do. Okay, whereas elastic net regularization is like regression is, it is a combination of both lasso and rigid, where that technology offer a balance between the feature selection and also coefficient shrinkage. Okay, lasso will not eliminate anything, like it will eliminate the potential features which makes the overfitting. Ridge, which will not able to or not do the elimination kind of thing. Elastic net is a combination of both lasso and rigid. Okay, this lasso is the other name of lasso is L1 regression. Rigid is another name is L2 regression. Okay, so these are some of the regularization technique, guys. Whenever you train the model, you need to use this kind of regularization technique so that you will not get the model overfitted. Okay, so there are different concepts available. So by just have a theoretical understanding of it, we're gonna see everything in depth. Okay, so we are just moving in a breath-wise manner. After that, we will be moving in a depth-wise manner. So yes, sir, over to you.
Yeah, absolutely. So, guys, regularization is we regularize, okay? With in regression, we regularize the data using these techniques. So, what we do is, so regularization technique is used to prevent overfitting in the regression model and improving the generalization performance. So, yes, rightly said by Raja that. Uh, Underfitting is when your training data is not trained properly. Like, and overfitting is when your test data. You need to remember that when your test data is not, it is not trained properly, then that will result into overfitting. So lasso regression, where we apply. So lasso regression shrinks the characteristics of lasso regression is it shrinks the coefficient of less important features Guys, do you remember that we have done feature engineering? So we were discussing those things. So we use lasso to remove that kind of some features from the model so that it goes towards the zero, potentially eliminates them entirely so that our model performs well. So you would have known that, oh, we are doing feature engineering. So here with Lasso, we can do that because less important features we are removing from so that our model will perform and be balanced. And we have to see that what kind of data we have and how it is behaving. Then we have to use Lasso. Okay. So elastic net regression is when we combine both lasso and rigid regression. So let me go to the second one. Rigid regression is shrinking the coefficients to all features towards zero but does not eliminate them completely. So it is like rigid. You know the word rigid. So it will take it towards zero, okay, but will not remove. So it will keep them, it will be rigid, so that's why name rigid is there. So it will keep features towards zero, but then it will not remove them completely, because if it does, then again there would be a problem, because maybe that data which is towards going towards data zero, so it will you will not get the good performance because you are there might be some important data features in that particular. So we need to, it balances kind of thing. So then we have elastic, where this model helps us to, it is elastic. When you pull elastic, when you have rubber, you pull with two hands, so you use both the hands, right? Similarly, lasso and rigid, the elastic net regression combines both lasso and rigid. One goes towards the zero and eliminates the lesser important features, the other goes towards zero and keeps them there. So elastic uses both like we use both the hands to pull rubber, one end south and north, right? Or one side, the other side, A or B side. Similarly, elastic net regression keeps both the techniques together and becomes elastic net regression, and offers balance between the features selection and coefficient shrinkage, because it's all about features, guys. So entire, see, feature engineering, we have learned that, okay, conceptually we'll apply that. But if you see, data is all about features, because you will build models on features, and based on that, and those features will be the building blocks for your model, and those features determine what kind of algorithm, what kind of techniques, what kind of model, and what kind of performance you will get in the model. That is very important. So it's a game of features, so you need to understand in data. So do you understand the features? And that's why features engineering is super important, guys. So then and only you can connect dots. Here we are connecting dots. What we have learned in previous sessions. Go and watch all the sessions 5 to 10 times and absorb the information, digest the information and apply. Do all the assignments and subscribe to our channels and press bell icon so that you can get all notifications, and give us feedback how we can improve all these sessions. Stay connected. Thank you.
Yeah, guys. So that's it from the supervised learning. Where under that we have learned about regression. So what are the type of it, how it works, what are the guidelines, and everything related to regression and theoretical concept we have learned. We're gonna see coding part in the later session, and before that we're gonna strengthen our theory concept like in a breadth-wise manner. Then we will be going in a depth-wise manner. Hope you guys have enjoyed the session. We are enjoying a lot. So yeah, guys,
So
let's
we are
meet in the next
doing
session.
we are doing breadth first search, and then we'll do depth first search. So it is very important to do breadth first search and then do depth first search. These are algorithms in computer science. So we are going according to that. So let us connect in the next session. Thank you.
Yeah, guys, we will meet in the next session. Bye.